Hello, how you doing? It's Mr. Doodle Math here in the Corona lockdown, the COVID-19 lockdown, right? And right now, what we're going to talk about is radical expressions. What I'm going to show you now is a prelude to conjugate, multiplying by the conjugate, right? And I'll show you why. So if you have this one, what do we got? 4 plus square root of 2 times 4 minus square root of 2. All right, so this is a conjugate. This is like a conjugate situation that I'll show you in a later video. But basically, you got two binomials. You're gonna multiply them by using double distribute 40, and then we're gonna simplify. So let's go. First times first, 16, outer times outer, minus 4 root 2, inner times inner, plus 4 root 2, last times last, minus the square root of 4. Okay? We good? Let's simplify this. All right? This is a mark. I don't even know why I didn't think. Since we can simplify this, I can just erase this 4 and magically make it a 2. The square root of 4 is 2, right? Then from here, we combine our like terms. So we got 4 root 2, 4 root 2. Same sign, add and keep. Different signs, subtract. So it'll be 4 minus 4, which is 0. So these cancel out. So now you're just left with 16 minus 2, which becomes 14. And that's your answer. So the thing about it is, whenever you're multiplying a radical that is the opposite, because the signs are different on the inside, that middle terms cancel out. And you're just left with a whole number. Okay? How you feel about that? You good with that? Cool. All right. So that is setting us up for the next move. All right. I think I put the next move in the same video. Let's do it. All right. Let's go. Here we go. Let us do. Yeah. Let's do that properly. All right. So we did FOIL radicals. FOIL of radicals. All right. Radical expressions again. Simplifying radical expressions. All right, what if we do this problem here? Let's see. Let's go for it. All right, we got 1 over the square root of 6 minus 1. Okay? Simplifying this, again, you can never have a radical in the denominator. And so what you gotta do is multiply, you gotta rationalize, right? And in rationalizing this situation, you gotta multiply by the conjugate. So, multiply by conjugate. All right, what that means is if it is the square root of something plus another number, it'll be the square root of something minus that other number. So the middle signs change. Okay, that's it. The only thing that changes is the middle sign. All right, so then for this one, it'll be, you got square root of 6 minus 1 times the square root of 6 plus 1. And whatever happens at the bottom got to happen at the top. So you mathematically make it correct, right? Because technically what you're doing is you're multiplying this by 1. Because this over this equals 1, okay? Now from here, let's do the math, all right? So at the top, you just multiply 1 by everything in parentheses. So 1 times the square root of 6, and then 1 times 1. 1 times the square root of 6 is going to give you the square root of 6. 1 times 1 is 1. That's the top. Now the bottom, you have to apply FOIL like we've been doing earlier, right? So it's going to be first times first, and we square root of 6 times the square root of 6 is going to get square root of 36, right? Outer times outer, it's going to be square root of 6 times 1, which is going to give you plus the square root of 6. Inner times inner, negative 1 times the square root of 6 is going to give you minus square root of 6. Now keep in mind, 1 times anything, it's understood that a 1 is in the front. And so I don't want to confuse you by saying by omitting the 1, but you don't need to write it down, right? Okay, so you got square root of 36 plus 1 times the square root of 6 minus 1 times the square root of 6. And then last times last, which is going to be negative 1 times 1, which is going to give you minus 1, okay? Now from here, you simplify this. The square root of 36 is actually 6, right? And then you got these inside numbers, these inside terms. They're like terms. They both have root 6 there. So yeah, same sign, add and keep. Different signs, subtract. So these will cancel out. So now you're just left with, if we rewrite everything, move over here, you're gonna have the square root of 6 plus 1 all over 6 minus 1, which is 5. So you got square root of 6 plus 1 over 5. That's your answer. Okay? That's it. This is multiplying by the conjugate. Whenever you have, let me show you what we started. Whenever you have a number at the top and a radical in the denominator, right? I think it was, yeah, radical in the denominator. You get that. You won't see it right away. You got to do the math to do that. Okay? Cool. You want to do one more example? Yeah, let's do one more example. A hard one, right? More challenging. Not a hard one, a more challenging one. All right, so what if this number here is 5 divided by -3 minus 3 root 3? It's pretty hard. I like that, right? Here we go. We can erase this because we know that's what we've been doing. All right, so look, we got, let's make sure it's clear for you. Let's put it right. 5 over -3 minus 3 root 3. That's the problem. Okay? You got a radical in the denominator, so we got to rationalize. That's, I don't know what I was gonna say. You got to rationalize. All right, which means that you got to multiply by the conjugate because this is a binomial, right? So here we go. So it's gonna be 5 over -3 minus 3 root 3 times -3 plus 3 root 3. And then you got to do it at the top, plus 3 root 3, right? So you have to do the top and the bottom the same way, okay? Now, remember, when you multiply by the conjugate, the only thing that changes is the term in the middle, is the sign in the middle. That's it. Everything else stays the same, okay? Now, let's do the math. Distribute 5 times -3, -15. 5 times 3 is 15 root 3. Okay, that's the top. Top is good and done. All right, now the bottom, it looks like this. You got -3 minus 3 root 3 times -3 plus 3 root 3. All right. So, first times first, FOIL. First times first, -3 times -3, +9. Outer times outer, -3 times 3 root 3, which is going to give you -9 root 3. Inner times inner, -3 times -3 root 3 times 3, right? Which is going to give you +9 root 3. And last times last, -3 root 3 times 3 root 3, which is going to give you -9 root 9. All right, take a deep breath. We good so far? All right, cool. Let's simplify. If you take a look in the middle, first things first, you got -9 root 3, +9 root 3. They're opposites. They cancel. You don't need them no more. Now here you got 9 times the square root of 9. The square root of 9 is 3. So you technically have 9 times 3 here. Right? Everybody see that? 9 times 3 is 27, right? And then you bring this 9 down. So it'll be 9 minus 27 because it's a minus sign, right? 9 minus 27, right? 9 minus 27 is what? 18, right? -18, right? Let's make sure all these numbers is right. So it's -18. All right, so here we go. We end up with, so we're gonna bring that over here to the denominator. So the denominator is -18, okay? Let's make sure we did everything right. So it's gonna be +9. This cancels out to 0. Then you're gonna have -3 times 3 is -9. So yeah, so we're good, okay? So from here, we just simplify. So 15, 18, 15. Those are all multiples of what number? 3, right? 3 is the greatest common factor. So you can take a 3 out of all of these. You take a 3 out of 15, you're going to end up with 5. You take a 3 out of negative 18, you're going to end up with 6, right? And then you take 1 out of here, you're going to get plus, plus 5 root 3. All right, so you end up with, so you got a negative, blah, 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 boody, bubbity, boo. What is you left with? Let me make sure we did everything right again. Negative and negative, positive, negative, 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 positive, negative, negative, positive. Yeah. So there's your solution. All right. There you go. So yeah, negative 5 plus the square root of plus 5 square root of 3 all over negative 6. All right. Again, so this is nothing but radical expressions. So you simplify radical expressions, right? And in this video, we were we're double distributing radical binomials. Binomials with radicals in them, right? By applying FOIL like we've been doing in the last chapter, right? And then we applied that to a radical expression or quotient property, right? So dividing radicals, okay? If you have any more questions, comment below. Don't forget to like and subscribe. Mr. Doodle Math.